What is key? A key is a piece of mild steel inserted between the shaft and hub or boss of the pulley to connect these together in order to prevent relative motion between them. It is always inserted parallel to the axis of the shaft. Sunk keys. The sunk keys are provided half in the keyway of the shaft and half in the keyway of the hub or boss of the pulley. And there are types of sunk keys. There are following types of sunk keys. The first one is rectangular keys. As shown, are wider than their height and are sometimes called a flat key. These are used on shaft up to about 500 mm or 20 in diameter. The extra key wind allows it to transmit greater torque without increasing the depth. The second one is square sunk key. Simply the similarity between rectangular sunk key and square sunk key is that its width and thickness are equivalent. And the third one is parallel sunk key. If no taper is provided on the rectangular or square sunk key, it is called parallel sunk key. It is uniform in width and thickness throughout. It is used where the pulley, gear, or other mating piece is required to slide along the shaft. The next is give keys or give head keys. Are tapered and notch machine keys that are used on power transmission key shafts to hold pulleys and gear tightly on the shaft. The head of the key serves as a conclusion point for hammering without damage to the shaft of the key. Next is feathered key. A key attached to one member of a pair and which permits relative axial movement is known as feathered key. It is a special type of parallel key which transmit a turning movement and also permits axial movement. It is fastened either to the shaft or hub, the key being a sliding pit in the keyway of the moving piece. Next is woodruff key. The woodruff key is an easily adjustable key. It is pieced from a cylindrical disc having segmental cross-section and front view as shown in the figure. A woodruff key is capable of tilting and in a recessed mill out in the shaft by a cutter having the same curvature as the disc from which the key is made. This key is largely used in a machine tool and automobile construction.
So another type of key is a saddle key. So a saddle key is a key for securing a member to a machine shaft that fits into the keyway in the secured member, and it is concave to grip the shaft by friction. So a saddle key is a key which fits in the keyway of the hub only. In that case, there is no keyway on the shaft. Unlike some keys, the advantage of saddle keys is that it doesn't sunk into the shaft and the hub. Instead, they are only sunk into the hub. So they either sit on a flat or circumference of the shaft. Power transmission is achieved through friction between the shaft and the key. So in a short term, a saddle key is for that fits in a keyway of the hub. It is only used in the hub only. So there are two types of saddle keys. First is the flat saddle key. A flat saddle key is a taper key which fits in a keyway in the hub and is flat on the shaft. It is likely to slip round the shaft around the load. Therefore, it is used to comparatively light loads. So here, it is only used in the light loads, such as gears or shafts. While the advantage of flat saddles is they are both prevent relative motions frictions that occur due to power transmission through the shaft key. Flat saddle key can handle better power transmission compared to hollow saddle keys, and it is much better to slip resistant. So flat saddle keys are better than hollow keys because they are usually used to have better power transmissions. So when it comes to power transmissions, it is used to have better process of having saddle keys. While hollow saddle keys are a taper key which fits in a keyway in the hub, and the bottom of the key is shaped into its curved surface of the shaft. Since hollow saddle keys hold on by friction, therefore they are suitable for light loads. It is generally used as a provisional fastening in fixing with setting eccentrics, clamps, and so on. So hollow saddle keys are usually used in having a concave shaped shaft like cams, because cams have a concave like lens. So it is usually used to it is held by a friction, and it is also suitable for light loads. So what are saddle keys used for? So saddle keys is used for in the keyway of the hub. It is likely to slip around in a shaft under load. Therefore, it is used comparatively in a light load. So, to summarize both flat saddle and hollow saddle, flat saddle is more likely used in hubs and in shafts. Unlike hollow saddles, they are slightly used because it is used by a concave shaft or any concave surfaces. So that's it. Thank you.
So, earlier, the other keys has been discussed by the other reporter. Now, I am going to discuss about the three keys: tangential keys, the round keys, and the spline keys. First, let us define every each of them. Tangent keys, or sometimes called tangential keys, are fitted as a pair at a right angle, where each key will stand torsion in one direction only. These are used in large heavy-duty shafts. Round keys is circular in section and fits into holes drilled partly in the shaft and partly in the hub. Spline keys are ridges or teeth on a device shaft that matches with grooves in a mating piece and transfers torque to it, maintaining the angular correspondence between them. Before we proceed, let us also understand or recall what a shaft is, what a keyway is, what a key is, what a key set is, and what is a hub. If you listen to the other reporters earlier, the shaft is a rotating machine element, usually circular in cross-section, which is used to transmit power from one part to another, or from a machine that produces power to a machine that absorbs power. A keyway is a long slot cut into a component to accept a key that engages a similar slot on a mating components, so that the two components do not move against each other. From what the reporters from earlier discussed, a key is a piece of mild steel inserted between the shaft and hub or boss of the pulley to connect these together in order to prevent relative motion between them. It is always inserted parallel to the axis of the shaft. Key set is the bed or groove in the mechanical part to receive a key. A key set can be milled horizontally or vertically. Hubs. Hubs are used to transmit mechanical power from a drive motor by coupling it to an output device such as a wheel or an arm. So what is the difference between a key set and a keyway? A key set is a recess in the shaft, and a keyway is the recess in the hub. To receive the keys and thus securely lock the components. Generally, the term key set is rarely used, as keyway is referred to both recesses in the industry. I hope you remember all the additional info. So, now let's go back to our topic. Tangent keys or tangential keys. As we can see in the picture, Tangent keys are actually a pair and is used to ensure tight. This pair of keys are placed right angled to each other and tangent to the surface of the shaft. Each key will withstand the torsion in one direction only. The two pair is a rectangular section. Each key has inclined slide face whose inclination proportion that is taper ranges between 1:260 and 1:200. With its inclined surface turned towards each other, the keys are driven into inclined key slots and hub key, which key with stand top in one direction only. Tangent keys can be usually used in heavy-duty equipment, such as articulated trucks, asphalt pavers, backhoe loaders, boom lifts, cold planers, compactors, dozers, compact track, and multi-terrain loaders. The keyway is similar to a parallel key except that it exits tangent from the outer shaft to the inner shaft. What happens on the side of the heels of each keyway from against which the key sits and transfers compressive force? This latter point means that for the reversible motion of the shaft, another key is needed along the tangent in the opposite direction. Typically, this will be offset by 90 degrees or 180 degrees on the shaft. Keys can be wedge, rectangular, or square shape, but rectangular double taper keys are used exclusively. Round keys. Round keys are used for moderate and heavy loads when tapered. It is said that the round keys are generally considered best suited for low power drives and medium duty, unlike Tangential, which is used mostly in heavy duty shafts. And why do round keys considered best suited for medium duty? This is because of its advantage, which is after assembling the mating parts, the key drill can be performed again. The round keys are circular in section and fit partially in the shaft and partially drilled holes in the hub. In the presentation, you will notice that the round key is inside, or should we say, between the shaft and the hub. The round key is attached at the top of the shaft, then the shaft is plugged into the hub. To make it more understandable, round keys are circular in section and fit into hole drills partly in the shaft and partly in the hub. Its taper size is 1:50. Just for additional information, the hub can also be called a sleeve or boss. In addition, the thickness of the hub, the key, is always divided into two. It is divided in the shaft and the hub. Half of the thickness of the key is in the keyway of the shaft, while the other half is in the keyway of the hub. Spline keys. The spline can be described a series of axial keys machined into a shaft, with corresponding grooves machined into the bore of the mating part, gear, sheave, sprocket, etc. Splines perform the same function as a key in transmitting torque from shaft to the mating elements. Splines are inbuilt key which are formed by shaping the outer circumference of the shaft and the inner circumference of the hub with tooth. With tooth-like structures, they are used where there is a relative axial motion between the shaft and the hub. These are used in the special application like where we have transmit the torque larger in portion than the shaft size. You can see these spline shafts in automobile transmissions and sliding gear transmissions. Occasionally, the keys are formed inseparably with the shaft that fits into the keyways fitted to the hub. Such shafts are known as spline shafts. These shafts usually have 4, 6, 10, or 16 partitions. Field shafts are relatively stronger than single keyway shafts. When you look at the front perspective of the spline shaft, you will see a broach hole in color. Splines are discussed. Splines are classified as straight-sided splines or involute splines. Both can provide strong resistance to torque forces. Straight-sided splines are parallel and sided and have 4, 6, 10, or 16 splines. The involute form is preferred because it provided for self-centering of the mating element and because it can machine with standard hubs used to cut gears. And for additional knowledge, let me share to you some of the advantages of splines. Because 4 or more splines are used as a compound with 1 or 2 keys, a more uniform transfer or torque and lower loading on a given part of the shaft hub interface the result. The splines are integral with the shaft, so no relative motion can occur as between a key and the shaft. Because of the multiple splines on the shaft, the mating element can be indexed various positions. Splines can either be straight-sided or involute. The involute form is preferred because it provides self-centering of the mating element and because it can be machined with standard hubs used to cut gears. Did you know that there are several types of splines? These types are parallel key spline, involute spline, ground spline, serration, helical splines, and last is ball splines. Parallel key spline. In the parallel key spline, the side of the equally spaced grooves are parallel in both direction, radial and axial. Involute spline. In the involute spline, the sides of the equally spaced grooves are involute as with an involute gear, but not as tall. The curves increase strength, preventing strength concentration. Crown splines. In crown splines, the side of the equally spaced grooves are usually involute, but the male teeth are modified to allow for misalignment. Serration. In serration, the side of the equally spaced grooves form a V. These are used on small diameter shafts. Helical splines. The helical splines, the equally grooved forms about the shaft. The sides they partially involute. It can be either minimize stress concentration for a stationary joint inside high load, or allow for rotary and linear motion between the part. Ball splines. In the ball splines, the grooves of the inner and outer part are formed as the linear braces filled with ball bearing to allow for free linear motion and even under high torque. To allow larger travel, the outer spline can incorporate channels to circulate the balls. In this way, torque can transfer upon a long shaft while traveling up down the length.